Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a systems and mechanical engineer and theoretical physicist. So today I'm going to go over my review of Stephen Hawking's A Brief History of Time. This is I wrote this way back around 1991 and then uploaded it to Amazon as a review of Stephen Hawking's work. So this will be a reciprocal system critique of Hawking. Here we go. And of course, as always, I will annotate this with some additional comments. This review will critique the conventional physical theory espoused by Stephen Hawking, after abbreviated to SH, in his best-selling book, A Brief History of Time. From the perspective of the reciprocal system, hereafter abbreviated to RS, the book is full of errors on practically every page. Still, I urge students and faculty to read it. SH does a good job of presenting the, quote, establishment's viewpoint, and it's worth pondering his thinking. The book's dust jacket proclaims SH to be the most brilliant theoretical physicist since Einstein, yet he begins his conclusion on page 171 with the words, quote, "We find ourselves in a bewildering world." This is a far cry from my work, my first book, The Unmysterious Universe, published way back in 1971. Hawking's later editions of this work are very similar, and so the comments here need not be updated. Continuing. SH is confused as to whether the universe was created or not. He states that in, quote, imaginary time, the universe has no beginning or end, no singularities or boundaries. It simply is. But in, quote, real time, the universe does have a beginning and an end at singularities that form a boundary to space-time and at which the laws of science break down. That's on page 139. The beginning singularity is, of course, called the, quote, Big Bang, when the universe was, quote, infinitesimally small and infinitely dense. Page 8. And infinitely hot, page 117, and space-time had infinite curvature. Wow. Time, and by implication, space-time had no meaning prior to the beginning, page 8. SH defines an event, page 23, as, quote, something that happens at a particular point in space and at a particular time. So one can specify it by 4 numbers or coordinates. This is the conventional 4-dimensional space-time, 3 spatial coordinates and 1 temporal coordinate, which is quite different from the 3-dimensional space-time of the RS, where each dimension is a dimension of motion, not of space or time individually. In the RS, that's the reciprocal system, space-time has an inbuilt expansion, and hence there is no need for a Big Bang, or dark energy for that matter, to explain the recession of the distant galaxies. SH states, page 33, that, quote, space and time are now dynamic quantities. When a body moves or a force acts, it affects the curvature of space and time. And in turn, the structure of space-time affects the way in which bodies move and forces act. End quote. Certainly, there is no physical evidence for this. Bare space-time is non-physical since it cannot be changed into something else. It is simply a reference system for motion. SH does not specify a mechanism for producing this alleged warping of space-time by the, quote, distribution of mass and energy in it, page 29. SH treats space and time as both purely relative, not absolute, that's on pages 21 and 33, and he says that, quote, each observer must have his own measure of time as recorded by a clock carried with him, and identical clocks carried by different observers would not necessarily agree. Of course, this subjectivist belief leads to numerous logical contradictions and is wrong. Space-time is the fundamental component of the universe and must thus be absolute. There's nothing for it to be relative to since it is itself the reference. An electromagnetic field fills the space-time of SH. There can be, page 19, quote, wave-like disturbances in the combined electromagnetic field. Page 38, visible light consists of fluctuations or waves in the electromagnetic field. But, on page 54, he says, although light is made up of waves, Planck's quantum hypothesis tells us that in some ways it behaves as if it were composed of particles. It can be emitted or absorbed only in packets or quanta. This is the old wave-particle duality. Compare this with the definition of photon in the RS, a linear vibration within a single space-time unit, which itself progresses perpendicularly, the combination thus generating a wave motion. SH states, page 31, that light rays too must follow geodesics in space-time. And page 28, quote, nothing can travel faster than light. In the RS, on the other hand, spatial motion is limited to speeds lower than that of light, but temporal speeds are higher. The speed of light is the midpoint of the speed range of the universe, not the upper limit. According to SH, page 117, 1 second after the Big Bang, the temperature would have fallen to about 10,000 million degrees. That's 10 billion degrees. At this time, the universe would have contained mostly photons, electrons, and neutrinos and their antiparticles, together with some protons and neutrons. SH does not provide a fundamental definition of electrons or neutrinos. The quark hypothesis does not include them. Quarks are the undefined elementary particles of matter in conventional thought. He states, page 65, that a proton contains 2 up quarks and 1 down quark. A neutron contains 2 down and 1 up. Page 73, one cannot have a single quark on its own. Confinement prevents one from observing an isolated quark or gluon, which carries the strong nuclear force. Page 75. The uncertainty principle means that the energy of the quarks inside the proton cannot be fixed exactly. The proton would then decay. Page 73. Another possibility is a pair consisting of a quark and an antiquark. Such combinations make up the particles known as mesons, which are unstable because the quark and antiquark can annihilate each other, producing electrons and other particles. End quote. Each subatom has a spin, but on page 66 he says, quantum mechanics tells us that the particles do not have any well-defined axes. And page 67, particles of spin 1/2 make up the matter of the universe, and particles of spin 0, 1, and 2 give rise to forces between the matter particles. Page 69, he continues, electric repulsive force between 2 electrons is due to the exchange of virtual photons, which have spin 1. And on page 70, he says, the force between 2 matter particles is pictured as being carried by a particle spin 2 called the graviton. This is all in contrast with the RS, in which each subatom is a set of quantized spins of a photon with definite axes. The mesons are actually cosmic atoms, that is, inverse atoms, in the process of converting to the prevailing structures of our sector. The apparent force interactions are not due to exchange of particles, virtual or otherwise, but rather represent an interaction between the particles and the omnipresent space-time progression. SH continues, page 117. About 100 seconds after the Big Bang, the temperature would have fallen to 1,000 million degrees, the temperature inside the hottest stars. At this temperature, protons and neutrons would no longer have sufficient energy to escape the attraction of the strong nuclear force, which, by the way, is totally ad hoc, and would start to combine together to produce the nuclei of atoms of deuterium. The deuterium nuclei then would have combined with more protons and neutrons to make the helium nuclei, and also small amounts of a couple of heavier elements, lithium and beryllium. Within only a few hours of the Big Bang, the production of helium and other elements would have stopped. SH doesn't question the validity of the nuclear theory of the atom. No mention is made of the instability of the neutron. How can an atom be stable if one of its main components is known to be unstable? Also, why don't the alleged protons in the nucleus repel each other? To explain the, quote, strong nuclear force is due to the exchange of unobserved gluons is mystical. Also, the alleged orbiting electrons are thought not to combine with protons to neutralize their charges, whereas other pairs of oppositely charged particles most certainly do. Finally, why should the production of new elements cease? It seems more likely that over the course of thousands or millions or billions of years, that atoms would continue to combine to form heavier atoms, and these would join to form ever more complex molecules. SH states, page 60, that, quote, since the structure of molecules and their reactions with each other underlie all of chemistry and biology, quantum mechanics allows us in principle to predict nearly everything we see around us within the limits set by the uncertainty principle. In practice, however, the calculations required for systems containing more than a few electrons are so complicated that we cannot do them. So, well, what good is a theory if we can only use it in principle? Compare that with my reciprocal system microcosmos database. SH continues, page 117. The universe as a whole would have continued expanding and cooling, but in regions that were slightly denser than average, the expansion would have been slowed down by the extra gravitational attraction. This would eventually stop expansion in some regions and cause them to start to recollapse. In this way, disk-like rotating galaxies were born. SH uses the uncertainty principle to explain the non-uniform density. He says, page 140, that there must have been some uncertainties or fluctuations in the positions or velocities of the particles. Using the no-boundary condition, we find that the universe must in fact have started off with just the minimum possible non-uniformity allowed by the uncertainty principle. And as usual, the RS explanation is much, much better. The two main forces of the universe are the space-time progression and gravitation. Where gravitation is stronger, galaxies and stars are formed. Where the progression is stronger, the galaxies move away from each other. Also, the latest evidence is that the formation of galaxies is not a one-time occurrence. Observations indicate that galaxy building is going on right now, just as the RS predicts. An average galaxy has 100 billion stars. SH states, page 82, that a star formed when a large amount of gas, mostly hydrogen, starts to collapse in on itself due to gravitational attraction. As it contracts, the atoms of the gas collide with each other more and more frequently and at greater and greater speeds. The gas heats up. Eventually, the gas will be so hot that when the hydrogen atoms collide, they no longer bounce off each other, but instead coalesce to form helium. The heat released in this reaction, which is like a controlled hydrogen bomb explosion, is what makes the stars shine. This additional heat also increases the pressure of the gas until it is sufficient to balance the gravitational attraction and the gas stops contracting. Stars will remain stable like this for a long time. Eventually, however, the star will run out of its hydrogen and other fuels. Paradoxically, the more fuel a star starts off with, the sooner it runs out. This is paradoxical indeed, for the larger stars should be the oldest and the smaller stars the youngest. In fact, the observed evidence indicates that the astronomers have the evolutionary sequence precisely upside down as the RS contends. SH continues, pages 83, 84, and 87. When a star runs out of fuel, it starts to cool off and so to contract. If a star's mass is less than the Chandrasekhar limit, it can eventually stop contracting and settle down to a possible final state as a white dwarf with a radius of a few thousand miles and a density of hundreds of tons per cubic inch. If the star's mass is greater than the Chandrasekhar limit, the star will eventually collapse to a black hole in which neither light nor anything else can escape. Again, in contrast, the reciprocal system says stars slowly accumulate mass rather than losing mass, and there's no end in a black hole. Rather, at the mass limit, a supernova type 1 explosion occurs and a red giant white dwarf pair is formed, or planetary satellite system, and both stars eventually return to the main sequence. It's interesting that SH proposes a radical theoretical change in the black hole construct. He says that actually a black hole would emit particles and radiation, and on page 115, the black hole, along with any singularity inside it, would evaporate away and eventually disappear. This is kind of amusing when we've been told for decades that nothing can escape a black hole. SH continues, page 46. The present evidence therefore suggests that the universe will probably expand forever, but all we can really be sure of is that even if the universe is going to recollapse, it won't do so for at least another 10,000 million years, since it has already been expanding for at least that long. Compare this with the reciprocal system. There are two sectors, the material sector and the cosmic sector. Outward spatial expansion of the material sector is terminated with a galactic explosion, which sends the matter over to the cosmic or inverse sector, where outward temporal expansion, the inverse of spatial expansion, occurs. This expansion, in turn, is terminated with a cosmic galactic explosion, which sends the matter back to the material sector. Thus, the main process in the universe is cyclic, rather than a singular one-time expansion. Also, the net total displacement in the universe is zero because the number of cosmic displacement units balances the number of material displacement units. Whereas SH states on page 129, the total energy of the universe is exactly zero. This negative gravitational energy exactly cancels the positive energy represented by the matter. So, coming to the conclusion here, having carefully studied this book, I think the supporters of the RS have nothing to fear. If this is the best popular rendition of conventional theoretical physics, The future looks bright for the spread of the RS, which is a unified general theoretical system. It's a theory of everything. Contrast the RS with the current so-called grand unified theories, which, page 156, are not very satisfactory because they do not include the force of gravity, and because they contain a number of quantities, like the relative masses of different particles, that cannot be predicted from the theory but have to be chosen to fit observations. Further details of the RS refutation of the ideas expressed by SH can be found in Dewey B. Larson's books, particularly The Universe of Motion. So I suggest that all of you read Dewey B. Larson's books and also take a look at my work. The simplest explanation of the reciprocal system is the unmysterious universe. The most advanced treatment is Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. And for those who want to apply the theory in practice, I have the reciprocal system microcosmos database and macrocosmos database. So we don't have solutions in principle, we have solutions in fact with the reciprocal system. So study the reciprocal system and prove it for yourself. Thanks for your attention.